Well, welcome back. Now we have our three illustrious speakers. What we're going to do is go over some of the questions from the audience, and some of the questions will be directed to the speakers, and some more will be to anybody who wants to answer them. And at the end, we're going to give them about 30 seconds to bring their final remarks, final words of wisdom, so to speak. So let's start first with Professor Chen. So one of the questions, and it's something that, of course, you're gonna realize this is something that's gonna come, and the question earlier about the products reaching the markets. Is these materials, these plastic materials that you can make from these biomaterials, is this expensive to create?
Uh, okay. This is a very good question. Um, so at the lab scale, uh, it would, nothing is too expensive. Otherwise, there's no scalability. In terms of our industry engagement, we have done the life cycle assessment, right? And it turns out to be not far more expensive than the petrochemical derived clean film. Yeah, well, that all depends also on the quantity eventually. So demand drives supply, but this is certainly a viable option. Yeah. Here we are talking about various sources of clean film. So that can include from soybean residue, can be from the brewer's spent green, as well as uh, shrimp shells that I mentioned at last presentation. In addition to that, one of the even cheaper way is to produce secondary packaging, not a full. I mean, it's not a clean film, but rather biodegradable secondary packaging like a container for the lunchbox, this kind of thing. Yeah, that would be even cheaper. Yeah.
Thank you very much. And that's because listening to Professor Oliver and Sagar about food safety and mycotoxins, one of the technologies that is revolutionary is this PICS bags technologies developed at Purdue, and I'm very familiar with the history of these and the fact that it's being used everywhere now in sub-Saharan Africa for storage of grains, which has reduced contamination. And I wonder if these type of packaging technologies that you develop, Professor Chen, can be used to store grains and in a way that is, because that's another problem these big specs have is that they will go bad for after a few, cycles of use. And that will become a problem, of course, in these places where you have to dispose plastic. So I wonder if this is something that your type of technologies and with biomaterials could be something that enhance the value of these big bags in Africa.
Ah, very interesting question. Um, I would say at this point in time, probably there's still some way to go. There probably still some way to go in terms of this harsh condition of once you package these beans, you need to not just store them but also transport them to the processing side and consumer retail end. All these may not be a optimum condition to use the biodegradable packaging, because as Professor Desaga mentioned, there are a lot of bugs in the. I mean, if they produce mycotoxin, that means there are microbe inside. So I'm worried that halfway through the transportation, then the bag may disappear. So I would say probably at the consumer retail end, this may be more have higher appeal and value rather than this packing bags. Yeah.
Thank you for that answer. I thought so too. It's an interesting conundrum, but I guess we get more heads over these, as Professor Edward mentioned. It's innovation. It's there for us to take it, I guess. So a question for Professor Oliver from the audience, and this is I guess probably a hard question to answer, but I'll let you go do your trick here. So what is the most important quality control for processors regarding food safety? And you can answer it from any, I mean, any processing. Let's go with agro processors of cereals. It's just easier. I don't know.
Yeah, no, that's a great question. And I think if we had 2 or 3 days, we might get the short list of what that really is. I think it comes back to prevention is key. That a lot of these safety risks, whether it's on the mycotoxin chemical side or biological side, some of these things cannot be processed away. And so in primary production and knowing that if inputs into maybe a cereal processor, knowing that the inputs coming in are safe is really the best safeguard to producing a safe end product. And that's not an easy thing. It's like innovation, it's not an easy thing. But increasing awareness and understanding of how to prevent, especially outgrowth of the fungus that can produce the mycotoxins is key. And that really is going to come probably back to moisture control. And so you put your contaminated soybeans that are not sufficiently dried into a PICS bag, you might stop insect growth, but you're going to create an amazing microbial growth opportunity. So really making sure that those early in the process ingredients are high quality and safe is really the best strategy.
Well, thank you for that answer. I'm gonna go and now ask a question for Professor Sager. Can processed foods be cross-contaminated with aflatoxin mycotoxins from processing machines, processing equipment at any level?
Okay, thank you for this question. This is not an easy question. Of course, everything depends on indeed cleaning your machines in between and decontaminating them, which is of course possible. I mean, you can clean or you can get rid of aflatoxins by using different chemicals. But yeah, of course, then you have to be sure that also those chemicals are not anymore on your machines. So this is indeed a very important question. It's still possible that also some molds are still present, due to not working with clean environment. So hygiene is very, very important for all aspects of food safety, but also for mycotoxin reduction. Yes.
Thank you for that answer. I guess it's a follow-up question to that, because all of you probably understand this quite well, is that we cannot diagnose, we cannot treat what we cannot diagnose, I guess is the best way to put it. And that requires good tools and good instruments. And the more I travel, to me, it seems that it has to be, as Professor Edward put it, has to be accessible and easy to use and easy to implement changes. And I think it's the same for not just biological hazards, but all chemical hazards as well as physical hazards. So is there and this is a question for the audience, for Professor Sager, is there any economical way processors can test for mycotoxins during intake of commodities and processing?
Yeah, thank you. This is also a very important question. There are rapid tests available on the market. For instance, for a very quick control of, let's say, aflatoxins. It's a dipstick type of test, as you have, for instance, pregnancy type of test. So it's this simple and easy to use, but it's a screening test. So you will just know if it is above or below a certain cutoff value. So those are available, and some of them also make use of smartphone technology so that you can easily have your results immediately on the smartphone. But nonetheless, I think they're still quite expensive to use very frequently. It depends on if you have a very huge company or if you are just a smallholder farmer. So for a category of smaller companies, might be still not affordable. So, but I know there are still a lot of projects ongoing to have more affordable of those very easy and simple test kits.
Thank you for that answer. Professor Oliver, what do you have a sense of how much biological contamination is coming from the water added to the household level, this burden of disease?
Oh, that's a great question, and it has a lot of answers because it's very situation dependent. I mean, one example I can speak to, research that our group did in Afghanistan was, 33, anywhere from 25 to 33% of water sources were contaminated with coliforms, which would be a fecal contamination indicator. And that was both well water and municipal water. And when we're talking about municipal, that means that that's reaching a lot of people. And so is it a significant source of contamination? Absolutely. And water is, it's just so foundational to survival anyway, but it's a big part of food production and food processing and becomes an ingredient. And so, we think about it as just as an important ingredient from an ingredient standpoint to be safe. You also can't improve sanitation of your equipment, whether you're trying to remove mycotoxins or other bacteria, if your water itself is contaminated. And so that too is no simple fix, whether it's deeper wells, different sources, making sure that waste and potable water are really distant spaced, are again big components of driving this, but also big infrastructure investments.
Thank you for that answer. So one more question for Professor Oliver from the audience. And again, these are hard questions, and I don't know if there is easy answers, honestly, but here you go. How do small producers keep food safe without ice or refrigeration? I guess it depends on the type of industry, but I told you it's hard.
That is a very great question. And this is like a PhD defense. Every once in a while you have to be put through your paces to answer the tough questions. Yeah, it's very commodity specific, but that is one of the largest challenges, both from a safety and from a food loss, quality, and waste, is cold chain and refrigeration. If we're talking about produce, that doesn't have an easy answer, especially if it's leafy greens. Trying to keep it cool, trying to keep it hydrated if you don't have a cold source is fundamentally right up there next to the impossible if it's cut, if it's actually been cut at the plant base. But it would motivate me to think about, I guess, a different crop that could be a little more tolerant of dehydration, of not needing cold chain. And of course, that doesn't necessarily align with consumer preferences or what they're interested in purchasing. So no, it's a big part of the long game investment for improving food safety and food security is finding economical, as again, cold chain is very energy dependent. It's going to take a lot of infrastructure investment. Again, how do we find practical solutions to that? And what kind of investment will it be? Remains a big question. So I answered a question with a question. I did that.
I think we all have done that before. Thank you. One more question for Professor Chen. So you live in a very small country, right? And you see the challenges that you have in Singapore are all there. And it's about getting the population thinking in the right direction, I guess, and talking about these pull-push strategies to bring these technologies or bring these changes, and sometimes some of which are behavioral. How do you see that the government of Singapore addressing food insecurity? Giving some examples of how, for example, the government has led to bring food safety or nutritious quality foods to the masses, to the point that you have now food waste, right? So could you elaborate on that?
Well, that's a great question. So I'm very happy to be among the panelists who are the expert in food safety. And as I entirely agree with the assessment, no food safety, no food security, right? No point eating the food, everybody gets sick. So that defeats the purpose. So to answer the question, Singapore government has established this new framework called Singapore Food Story. So under which there are three pillars. One is urban farming. So this is to push up local production capabilities to mitigate the disruption due to supply chain disruption. That can be COVID-19, can be other infectious disease or pandemic in the future, which bound to happen. The second one is novel proteins. So we talk because Singapore we don't have animal farms, so we import all the food, including meat, from overseas. The question here is how can we beef up meat proteins production level? Of course, we will not free up land to allow cattle farm or a pig farm. That's beyond the point. But Singapore is surrounded by seas, so aquaculture is one of the ways to push up protein supply. But we are also looking for alternative protein sources that may include the protein-rich microalgae or insect protein. So recently, Singapore became the first country to have approved uh, culture meat from the lab. There is actually the American company called Just Incorporation was famous for the making the egg without chicken, right? So now they are making the chicken meat without chicken altogether. So this is approved in Singapore. Why Singapore has become the first country to approve this? There's a lot of reason for that. First, we do not have animal, no, we don't have animal farm, so it's a lot easier to worry less about job displacement for farmers. And also, this is part of the technology-driven production scheme. So, and that is a story about the alternative protein sources. The third one is actually related to food safety, science, and innovation. So under the food safety, Singapore food story, there are three pillars. My university is the host for the food safety, science, and innovation. So I hope to have a lot of interaction with Professor Oliver and Professor Desaga. With Professor Desaga even better because I study in Belgium, although in French. So there's a lot of connection here and there. So I hope to have interaction with panelists. But to answer the question, so there is a framework to not just to beef up primary production and look for alternative food source, but also improve food safety risk assessment of all these novel food, and also along the way improve, increase the awareness of consumers towards novel food. Because if there's no consumers buy in, no matter what we do, it will be a zero-sum game because no one buys it. So this is how we, as government-driven approach to enhance the food security in Singapore. But we also work with the food industry to sort of incorporate our innovation in the processes so that to have a better new ways of producing food and a more efficient way of producing the existing food. Yeah. So this is my 2 cents of assessment of the situation in Singapore. I just want to add one line is that Singapore is so small. I don't know how many times you read news about Singapore, maybe once every 10 years, but so that's to say that no matter how high tech we can go, the impact is not felt. So we are hoping that with the global trend of people moving to the urban area to live in, there will be more and more urban farming appreciation. So the idea here is that we hope to propagate our urban food system to the region, and so to create a real impact. And then first we start with ASEAN, and then maybe later on beyond ASEAN. So only then we will see that everybody benefit from this uh, efficient food system, and then we grow together in terms of enhancing food security. Yeah. Sorry, I talked too much. Yeah.
Oh, Professor Chen, this is great. This is wonderful. I think everything starts with good foods and safe ones, and
Yep.
understanding our needs, and from there we go. I think I have one more question for Professor Sager that just came in about extrusion technologies. Would extrusion technologies, which is just heating to create these interesting consistency type products such as snacks and why not, would these type of processing kill or reduce aflatoxin or mycotoxin contamination in a food product?
Yeah, I know there has been a lot of research on extrusion. It's not completely my field, but I know in the US there are some groups working on that. And I thought it was mainly on the fumonisins that they did this work. And indeed, as most of the processing techniques, there is some reduction. But also here, I don't think it's a complete reduction. But I cannot say much more about this, but there is for sure a lot of research done on this.
Excellent. Thank you, Professor Sager. So now we have reached the end of our panel. I would like to offer you 30 seconds to tell us some words of wisdom. And we'll start with Professor Chen, then Professor Oliver, and then Professor De Sager about I think the world has seen tremendous pain, I would say, in this year, and frustration, but also have seen tremendous hope. And I think there is hope in technology, and there is hope of understanding, and hope in science. And I want to stress that. So I wonder if you can, in 30 seconds, tell us how do you see the world it's going to be in 2021? Where do you should think we should focus our attention in your respective areas of focus, of course. But where do you think this technology should go to help us? Go ahead.
Ladies first. I will speak the last for once. Yeah.
Professor Oliver, go ahead.
No, you're right, Juan. It's while a challenging year, there's still been some impressive things that happened, and I think just looking at the possibilities of the vaccines and the timing and the amount of the speed at which they were developed is a real testament to science. And what I hope is we can keep that positive attitude to really make our best effort to make sure that the investments in food security aren't reversed. And we know that there have been significant setbacks because of COVID-19. But how can we come together and be our best to prevent collateral damage in that space is huge. Food safety, of course, is a part of that discussion, but there's a lot of big picture, big challenges that come together to make sure that the world doesn't have a massive setback as a result.
Thank you. Professor Sager.
Yeah, thank you for this question. And yeah, it's very nice to give messages of hope. And every negative thing like this year has also some positive results. And one of the things which are indeed very important concerning food safety, not only mycotoxin, but in general, is awareness creation. And I think due to this, let's say, the fact that we are now all using Zoom and all those kinds of digital platforms to talk to each other, might even create awareness for much bigger publics who before could not afford to come over to a conference somewhere in a part in the world. So I think everything starts with awareness creation. If we know that, then the technology can help us for prevention, reduction, mitigation, and so on of all the problems regarding food safety.
Thank you, Professor Chen.
Right. I would say that we can look for improvement in efficiency of the food system. This is very amazing when you look at the single cell in mammalian cell, bacterial cell, very little waste, right? So we recycle the building blocks from nucleic acid to amino acid. We recycle them. Well, so when we talk about food system, there's so much wastage. So this crisis would be a good time to turn things around, to improve the efficiency of the food system, so that we don't go everything go one-sided, either push for GM crop to push for the production, or now is everything's land meat. So we should actually go for efficiency, reduce waste, and create this alternative solution as options. Only then we would sort of improve the overall food system and then achieve this food security, not within just one country, but around the world. Yeah, this is what I hope to see. Yeah.
Well, thank you very much. I just want to say a few words to thank the panel, Professor De Sager, Professor Oliver, Professor Chen. You've been grateful for with your times, and we appreciate bringing these words of wisdom and hope to our attendants. Again, we will do one more day of this symposium tomorrow at the same time. Be ready for those very wonderful presentations. Today, I just want to say thank you to the AOCS, the Soybean Innovation Lab, and IFT, and these other organizations that help us bring these speakers together and bring you great information for your companies. With that, thank you very much and stay safe.